So we start. Okay. Now today's class is from the paper itself. The paper is Global Vectors for Word Representation. The authors are Jeffrey Pennington, Richard Socher and Christopher D. Manning, and that's it. So what we had done in the last class was we had talked about this particular numbers, right? So we had talked about this, what is this matrix called? Word co-occurrence matrix, and then from this particular co-occurrence matrix we had computed. So we had claimed that the probability that which is context, which is center word in this case, in this expression, which is context word, which is center word. So I is center word because given center word, whether J comes in the context of it or not. Okay. So in this, which one is context word, which one is center word? So I is my center word and K is the context word, and similarly steam is my center word and K is my context word. Okay. Now, so we had talked about this particular cost function in the last class, and I did not really want to derive this one, but what we are going to do today is we will try to derive this one. Not derive exactly because this is not mathematically rigorous thing. So, okay, I want to get this one. Okay, so let us start with this now. So I checked it, this seems fine. Okay. Now, all right, so we start. So, section 3, the GloVe model. Now, why are we, so what is P of j given I? We are writing that as Pij, and that is equal to my Xij divided by Xi. Okay. Now, what we are saying next? So, what is it that we want to do? What is our goal? What is our goal? So, our main goal is to learn good word embeddings, but how do we want to achieve that? So, there are two kind of goals. There is one primary goal that we want to achieve, which is to learn word embeddings, and then there is a pseudo goal through which we want to achieve our primary main goal. Okay. What is this pseudo goal in this case now? We want to make, we want to have a training setup for which we will train the whole thing and our byproducts will be good word embeddings. Okay. So, the question here is now, okay, this is Pij, this in itself is of any use? This Pij in itself, is it of any use? Why not? We said that this Pij itself, huh? Right, but what we saw is more informative regarding the relationship of words. So, instead of Pij, what we are saying is we are using Right. So what is it that we were using? We said from that table that we had, right, that ice, steam and everything. So we have Pik divided by Pjk. Okay. What is P? So for example, if I want to talk about that, which one is context word here, which one is center word here? I is center word, K is context word, J is center word, K is context word, right? So in our that example where we had ice, steam and what else? So ice, steam, right, solid, what else? Gas, water and fashion. So what will be I in this case, for example? Ice. What will be J? Steam. So one context word was ice, and then we say one center word was I, which is ice. So keeping ice as center word, we said context word can be solid, gas, water, fashion. Okay, and then we said keeping center word as steam. So our context word can be again solid, gas, water and fashion. Okay, so we have this setup now. Now what do we eventually want to capture? We want a function of what? We want a function of, so I am going to use that same terminology that we used in word to vec, which is different from the paper, by the way. So you need to pick one of the two. Now V of I, comma, V of j and U of k. Does this make sense? Why V of I? Because I here is a center word. Why Vj? So let me explicitly write this. We are using for center word. This we are using for context. So ice right now is my center word, other words are my context word. I, again J is my center word and K is the same context word. Okay. So what we are trying to see here is we want to have a function of these three vectors that gives me this. What do we do next? What can is this a number? This is a number divided by number, so finally a number. Okay. Now, so this whole thing is a scalar. Now, what about this? If you see the arguments of this function, right? If you see arguments to f, what are they? So these are vectors, right? These are vectors, and in our example they are vectors of size 300 cross 1. Okay. Why 300 cross 1? Because every one is 300 cross 1, that is what we are saying. So what we want to do is we want to parameterize this function that gives us this. What does it mean? These are the word embeddings, okay, and these are my parameters too. So what we are saying, I want to have a function. Which function? I don't know it yet. I am going to talk about the possibilities of functions, but those functions are, so this function is a function of Vi, Vj, Uk, these are the only three things here. So we want to find a relationship between this number that we are getting and this number we are getting here. So can F be a neural network? What do you do in neural network? So there is an input, there is a given output, you try to learn a function that maps input to output. Okay. Now F can very well be a neural network, but authors say we don't want it to be so complicated. So what else can it be? So firstly, their observation tells us, ये चीज होना बंद नहीं हुई यार. Okay. So their observation tells us, okay, they say this F, instead of being, function of all these three variables, it better be a function of just what is the difference? What is this new thing now? If you see this particular function f, it is a function of 3 parameters, and this one is now a function of just 2 parameters, but it still has all the 3 word vectors. Okay, so you go from here to here by saying I don't want any generalized f that takes these parameters to this one, right? I want to keep on restricting this, and then is it a foolproof thing? No. So idea here is I have this, I start to do something, I finally say this equation I have, there is no mathematical backing to this, only your intuitions, and then how do you prove you are right? Using that J, train your model, right? If your trained word embeddings, if they have the properties that you are looking for, then whatever you have done seems to make sense. Okay, else you can throw it. So this particular function takes 3 arguments. Now we are saying we just want only 2 arguments. But why? Why do we want only 2? But you still have, see, all these arguments, they are not as such, they don't follow the structure of a proof. It's more like intuition. We did this, we did this, we did this, and then this worked, and we are happy. Okay, that kind of thing. Right, right. So tell me one thing. If, so this is a little bit digression, but we can do it here. Okay, so let's say this was, so somewhere here we have origin, let it be. Okay, now this was our woman, so what I want is king, man, and then something like this happens, queen, woman, right? These 2 vectors, what are they? And then in this we said that this is vector king, this is vector man, this is vector woman. You take vector addition of, you do that vector thing that we did, and then finally this vector somewhere here is going to, it should be able to give us vector queen. At least it should be able to capture these linear relationships. Okay, now tell me one thing, do we really care what is king, what is queen, what is woman, what is man, or just these vectors are more important? If I take this axis, if I take my y axis, x axis, rotate this by 90 degrees, will these vectors change? Will their absolute things change? But if you rotate this vector now gets changed, the values whatever here. So let's say if this was, what can I say here? This is 4, 2? No, 2, 4. If I rotate this will be some other number. But if I rotate everything by exact same angle, what does it mean? Does this relationship still holds? King minus man and queen minus woman will still be parallel. That equation that we wrote that day, that will still hold. So this is true for all word embedding kind of things, that what you care about is the relationship between the words and not the absolute content of the word vectors. If you rotate them, that is fine. So what they are saying here is, you have these word vectors here, what we care about is the differences between them. So that we don't really want to capture too much about the vector itself, but we want to capture the relationships which is given by this linear relationship by subtracting one vector from the other. Okay. Moreover, why do they do this has other reason too, so we will come to that as well. Now this thing is equal to what comes from up there? P of ik divided by P of jk. Now, so again tell me, we don't want this to be a neural network, we don't want this to be a very complicated thing. So tell me, what is a simpler idea, what is a good replacement for this f? Dot product, right? So this is excellent. So what they say is, what we do, so let me just write here. So f vi minus vj transpose uk is equal to pik pjk. What is this side now? What is the argument to f? What is the argument to f now? I mean, what is sitting this inside this thing now? Is it a scalar? Okay. So what we are trying to do is, we are trying to simplify our f as much as we can. So this is a scalar now. We go next. So this is essentially equation 3 of the paper. Okay. Now, what they say next is, see, if you look at the word co-occurrence matrix, xij is same as xji, right? So the distinction between whether a word is a context word or a center word is rather arbitrary, because they are interchangeable. Okay. So they want to capture this thing too. They want to capture this symmetry, that okay, if I just take the transpose of this matrix, so if I take the transpose of this matrix, and whatever was center word, that becomes context word, and whatever was context word, that becomes center word, that should also work for me, that should keep things identical for me. Okay. So they want to capture this symmetry as well. Now what they say? Symmetric means if I change my context word to center word and I transpose the matrix, right, should be the same equation that I should get. Not right now, okay, but they want this. And why do they want this? No, because so the idea is this, that the whole thing looks symmetric. So it is better you capture this thing in your equations as well. Okay, because something which is prima facie symmetric, and if you don't capture it in your equations, then the word embeddings that you learn may be not as good as which you will learn in case of symmetry. So what is so special with this symmetry? You can prima facie see it. Why? By if there is a context word, it is going to be center word in some case, and xij is exactly equal to xji. So what is the definition of pik? So if you look at this one, so pik is going to be xik divided by xi, and this is going to be right. Okay, so our goal is we should be able to exchange context words with center words and still get the same kind of equation. So first let us do, and then we'll know what does it mean. Okay, now they say that to restore this symmetry, so let us come back from here. We start from here. They say this number is of importance to me. Okay, I want to predict this number. I want to be able to predict this number. I parameterize a function f that does this. Now f can have so many possibilities. I want to simplify the possibilities for this f. In this process we said I want this to be a dot product of these guys, but the problem with the dot product of these guys is something that I see prima facie symmetric is no longer symmetric in this equation. So we want to make this equation symmetric now. Okay. Now, so they say that so this is something, so first we require f to be a homomorphism between groups r plus and r0 cross. Okay. So this is something I am not going to decode. What they say is something like this should happen. Okay. Now tell me which function satisfies this equation, which function satisfies the property that we require from this equation. And log of m minus n is same as log of m divided by n. What else? So E of A dot B will be same as E of A plus, no. So, E of A plus B is same as E of A dot E of B. Okay. So, exponential is a solution to this equation. So, what we can write here is exponential is a solution to this equation, and all right. So, can you hear me back? Okay. So, let us start again. So, exponential is solution to equation 4, and this basically comes from equation 3. So, if I equate this to Pik, this is what I get. Now, so can I write Vi transpose Uk, that gives me log of Pik, and that basically gives me log of Xik minus log of Xi. This is fine, and this is equation 6 in the paper. Are you following? How are we going from one step to another? See, the reason, leave out reasons, because we are not doing a mathematical proof. So, it is not that first one logically follows in some sense, in the sense of proof, it does not. Okay. So, we started from here. What was our goal? We want our parameters on left hand side. We want to be able to learn this thing. Okay. And these are my parameters. Now, if I leave it completely open, there are so many possibilities, I do not want to do that. So, what we said is, we want this to be of type dot product. Okay. And then we said there is something called symmetry, and to be able to restore symmetry, we want homomorphism. So, then we use that property. Then by equating equation number 3 and 4, we are saying this comes from, and this is straightforward, right? This is straightforward, because what was this thing? This was equal to Pik divided by Pjk. All we are saying is Pik is this guy, and Fvi transpose is this guy, which is equal. So, this is straightforward. Now, all we are doing here was, we said F is, so yes, so F is e to the power this, so just apply log, maybe take log both sides, and you get this one. So, this is fine. Okay. Now, what is wrong with this equation? Is this equation symmetric? This symmetric, this will make more sense here now. This will make more sense here. So, now tell me, can you exchange I with k in this whole equation? This is what we mean by symmetry. K is our, which word in this case? Context. I is center. But the whole thing that we have seen, this is a symmetric matrix, so you should be able to exchange rows and columns. without any change, right? But if you exchange rows and columns, what will change? The roles. What was context, that becomes center, and so on, and vice versa basically.
Sir, but अगर order same, तो value will be same ही रहेगी अगर हम column का row change करें.
This is precisely what we mean by symmetry. See, everything is same and prima facie you can see it. So you want your equations to capture this fact that if I exchange I with k, nothing changes. Okay? Is this equation symmetric? No. Is this equation symmetric? What is wrong with this? What is wrong with this equation? So is this fine? Is this fine? This one? So this is problematic. Okay? So this one basically so does this symmetry make more sense now? All we are saying, you should be able to exchange context word with center word. In this case, can you do? This is a dot product. All you are supposed to do is UK transpose VI, same thing here, and so on. Okay? Because log xik is going to be same as, so this xik is same as xki. Okay? So the problem here is this one. What do we do now? How do we fix this? So there is no mathematical way to fix this. Okay? This is what it is. And if this is not symmetric, this is not symmetric. But what authors want? We want this equation to be symmetric. How do we enforce it? Yes. So we'll remove this. So we'll remove this. So as they say, next we note that equation 6, which is this one, would exhibit exchange symmetry if not for log xi on the right hand side. However, this term is independent of k. So it can be, right? So this term is independent of k and depends only on I, which is what? Which is my center word. In this equation, I is my center word right now. Okay? So this term is independent of k. So I want here not exactly log xi, but some term which is dependent only on I, not k, I. Okay? So what we say is, okay, these are equal now, this is fine. Coming back to your question in the last class. So this thing, log xik, they say replace this thing with a bias for I. Okay? So log, not this side, but so what they write here is, this is left hand side, so this is my VI transpose UK minus, so I take log xi this side log xi equal to log xik. Okay. Now with this, what they are saying, since this is independent of I, you assign a bias. So Vi transpose uk plus bi equal to log xik. Is this equation symmetric? Everybody is okay until now what we have done? So is this equation symmetric? Obviously not, because this term depends only on I. So what do you want to do next? So you add another bias corresponding to J. Right, K. Right? But you need to capture this fact that this is for V type of bias and this is for U type of bias. Okay? How do I write this U here so that मेरे को tilde की जरूरत ना पड़े? U there. No, U is for a vector. This is a scalar. So maybe I'll write U here and V here. Say that again.
सर ये दोनों साइड ऐड नहीं होगा इक्वेशन के अंदर, अपन मतलब ऐसे डायरेक्टली ऐड करेंगे.
See, what we are saying is right hand side known to us? Right hand side is known to us? Left hand side? All parameters. So I am just trying to find a function which I want to equate with this. We initially started with what? We initially started with f of Vi, Vj and Uk, right? And then we kept on saying this is too general, this is too general, this is not symmetric, my equation is symmetric, so we want to make it symmetric, so do this, do that, and finally we are saying this one. Now the only claim here is this is one of the probably infinitely many possible functions who are candidate for this one. Who are candidate for this one. Okay. So this f can have maybe infinitely possible candidates. We don't want any of them. We want one of them. And there is absolutely no claim that this f is the best one. Okay. What is our claim? What is it that we want? We want to have parameters and what is given to me from the corpus, we want to equate them and I want to learn those parameters to do what? To learn good word embeddings. As long as I learn good word embeddings, I don't care the f that I have chosen is best or not. So there is absolutely no claim to say here that the best version of this f is this one. Okay, this is just f function f. Am I using capital F? This is just f function f. May, in fact it is may not, there is absolutely no claim. We don't even want to do this key, it has to be best, because then our whole hard work that we are doing will shift towards finding a best f, and that best f may not give me good word embeddings. So the whole work will shift towards finding a best f, but our goal is to find good word embeddings. Okay. So they say we want to do this. Now is this equation same as what we wrote yesterday? So let us go back to that. This is same, right? Vi transpose uj bi bj minus log xi, because you shift that thing to left hand side. Okay. So this is same as that. Now let us rewrite this, and then right. What happens here now? So I basically bring it to this side. Vi transpose uk plus bi, when this is, when bi is the center word and b when it is the minus log x I k. Okay. This is our cost function. What is problem with this? This now we have talked about everything in the last class. What was problem with this equation? You have log xik sitting there, xik can be 0. So how do we solve this 0 problem? We say there should be a function x I k, and xik will be 0 when, I mean f of xik will be 0 when xik is 0. We want to sum this over I is equal to 1 to mod v, j is equal to 1 to mod v, and we want to minimize this whole thing. Which one? Square, right. Thank you. So we want to minimize this whole thing. Just to recap, see, you want to come up with a cost function. Okay. And what is the goal of keeping a cost function? That when you will minimize this cost function, the corresponding word embeddings will be good. And what do you mean by good? They will have at least linear relationship properties. Okay. If so happens, then as an author, as a researcher, as a scientist, as a project person of this project, you decide that your goal is over. Tomorrow someone else will come and try to improve these things, right? But your job, you think, is over with this. Then you publish this paper, it turns out that the world goes mad, right? So then actually you have done a very good job. Now there are properties of this f which I don't have time to talk about right now. Or can I finish? I want to finish GloVe. हाँ? 1 बजे? झूठ बोल रहे हो तुम? लंच? Okay. All right. So what do we do next? What are the properties with this? What are the properties of this f? F should be 0. And you see, so they say f of 0 should be 0. They also say f must be, so f is a continuous function and f should be non-decreasing. And f should be large values of x. So why f of x we want to be 0? Because we don't want this quantity to go up, right? Done. Next, f should be non-decreasing. Why? X takes input as xij. So if this is your xij, okay, and this is what? This is your f. What will happen if this is, let's say, something like this? Let's say xij is 3, xij is 5. What is happening in this case? This will be more for, so this can be seen as weightage to this. By this term is a weightage to this whole thing. I give weightage to this whole thing equal to 0 when xik is 0. So I don't want this to have this kind of behavior. Why? Because see, if xik, so if this I and k, if they co-occur only 3 times in my corpus, I don't want their weightage to be greater than those which occur more. Shall I repeat? See, what does this 3 mean here for xij? That means I and j co-occur only 3 times in my corpus. But what is the value of f? Higher. So the weightage given to this thing is higher for this set of I and j. But if this value is 5 and the function is like this, what happens? I will give, my f will be smaller for this whole thing, in which case when xij actually appear more number of times. Now what is this last thing? This you should be able to answer. So things like the, of the, I mean this is an overkill, right? Of the will appear so many times. So f should be small for large values of x, and what they say, f is this. Okay. Now from here I will switch to the paper. This one, okay. So they say that for their work this function works well. So what was the function that we wrote down? X upon x max to the power alpha, okay. But if 1, it is greater than x max. So if this is your x max, this will flat out to just 1. See this last part, does it make sense? By if your x is greater than x max, then what do? Make it 1. लिखा हुआ है उसमें, right? So this is done. X max is some value that you choose. where this is going to flat out. Okay, right? Now what is x upon x max? Just x upon x max. X max is going to be a constant, so this is just x by c, a line that takes me from 0 to this part. Okay, now but what is x upon x max? So what authors again figure out is that if you put alpha equal to 1, it does not work well. What works better is if you put alpha equal to 3 by 4. Okay, which is a coincidence, they say, with the word to vec as well. So you don't get a linear thing, it should have been. So it's not x upon x max, it is rather x upon x max to the power alpha. And alpha, they say, best for the value of alpha that works best for them is 3 by 4. So then this is the project page for GloVe. What they say here is, so Chris Manning once said, so when they were looking for words closer to frog, they got frog, toad. So until then they were happy that okay, these are good words closer to frog. But then they saw words like litoria, a word that I can't even pronounce, rana, lizard, and so on. They looked into dictionary and it turns out these are basically types of frogs only. So you can't make a system that works better than this. Something that we didn't know, but the system could capture the meanings. Now these figures we have, now you see here, man, woman, sir, madam, here, heiress, queen, king, emperor, empress. So you don't care what is the exact vector. What you care about is these linear relationships should make sense. Company CEO, okay, city zip, and slow, slower, slowest. You see almost the same kind of relationships. Done for today.